My name's Tyler Kovacic. I'm a design technology specialist here at Teecom. And that means that I work on applying machine learning and artificial intelligence to our core design processes and technologies. My name's Tyler Kovacic. I'm a design technology specialist here at Teecom. And that means that I work on applying machine learning to our core design processes and technologies. So at Teecom, we're excited about the potential for machine learning to affect pretty much every aspect of the architecture, engineering, and construction industries. And that's because machine learning works in a fundamentally different way from traditional programming. And that is that you can build useful tools by providing a library of examples rather than providing explicit instructions on what should happen. So machine learning is fundamentally the ability to learn from experience, to program from experience, rather than to specify explicitly how something should happen. So you can build useful tools that would be difficult or impossible to describe with traditional programming techniques. And you can do that simply by working in the ways that we already do, which is collecting libraries of past experience. Artificial intelligence has always been a kind of buzzword. Machine learning is really the ability to save experience into a model that can be executed in a useful manner going forward. So machine learning is simply the ability to look at examples of data and save the results of looking those at examples for future use. Machine learning has been around since basically the beginning of computing. Machine learning was first described in 1954, but it has only really become useful since about 2012 when computational power and the amount of data that we have to train these models was enough to really make them generally useful. So we're seeing the impacts of this everywhere. All kinds of things that have been intractable problems in the past have recently become almost trivial in some sense. Computer vision is one of the most transformed areas recently. So we're seeing better results in image recognition, in the ability to segment objects from backgrounds, in natural language translation, in predictive texting. Pretty much every aspect of computing that relies on a difficult to describe function will be changed by machine learning if it hasn't been changed already.
Action.
So machine learning is the ability to write programs with data rather than writing them explicitly. So you basically set up the pathways for a useful program to exist somehow, and you let that come into being simply by pointing the model at a collection of data and letting it find the function that fits the data that you've given it.
Great. We see this as a natural fit.
Right. We see this process as a natural fit for the architecture, engineering, and construction industries because this is, to some extent, what we already do. Designers, architects, engineers have to work with problems that are difficult to describe explicitly, but that can be fairly compactly described by providing examples. And so this process will simply make what we're already doing executable in software. So the architecture, engineering, and construction industries are already based on building partnerships around meaningful past experience. So you look for partners in some building project that have the requisite experience to help you solve your problems. Currently, that experience is stored basically in people. We take on new designers, new engineers, and we train them through the experience of a firm. What machine learning will allow us to do is to take the past experience of some firm and train that explicitly in a model that will make it testable, experimentable, and exposable to improvement in the future. At Teecom, we're working on applying machine learning in two directions. The first is building a full custom software stack that's enabled by machine learning that fits exactly into how we work with building information models today. This is everything from time series analysis to tell us where we can build new tools in the future to help improve our process, to learning spatial relationships on the building information models themselves. So what that looks like is training neural networks to solve the hard-to-describe design problems that we are currently facing in our work today. The second way is a platform that we've been calling Architecture Ex Machina. And this is more of an open source initiative that's organized around collecting people, collecting information, collecting ideas.
Action?
The second way we've been calling Architecture Ex Machina. And this is really a platform around which we want to collect people, ideas, resources, experiments, all sorts of projects that collect our experience in applying machine learning directly to our design process and have open conversations with people throughout the industry. My name's Tyler Kovacek. I'm a design technology specialist here at Teecom. That means that I work on applying machine learning to our core design processes and technologies. The thing that I'm most excited about for the future of machine learning in AEC is that it will change pretty much every aspect of the way that we do design. Machine learning is fundamentally the ability to write programs with data. So instead of providing explicit instructions, you provide a data set of examples of how you would like a program to work and allow the machine to find the best fit for that data. We see this as a natural fit for problems that architects and engineers are already working on because these problems don't have one-to-one relationships with their solutions. There are difficult to describe paths that can be taken to solve many different kinds of problems. Machine learning has been around basically since the beginning of computing. The plan for a neural network was originally laid out in around 1954. But they didn't really become useful until the past 10 years or so because we needed to expand the size of data sets required to change these models and the computing power that was necessary to power that training. The first significant result in applying neural networks to a previously intractable problem came about in around 2012 with the development of AlexNet on the ImageNet dataset. Machine learning is fundamentally the ability to write programs with examples. So instead of providing explicit instructions on what you would like to happen, you simply point it at a data set of examples of what you would like to happen and allow the training algorithm to find the best fit for that data.
Is this a new concept?
The concept has been around since basically the beginnings of computing. Neural networks were first described in around 1954, but it took until 2012 with the development of AlexNet on the ImageNet dataset for the computing power and size of dataset necessary to train these models to be developed. We see this as a natural fit for the kind of complex, hard-to-describe problem that architects and engineers face every day, because these problems don't have explicit one-to-one relationships with their solutions. There are a multitude of different solutions that could exist. So what this paradigm allows is the ability to create programs by learning from experience. So the architecture, engineering, and construction industry is already based around building partnerships with those people who have the requisite experience to solve a specific kind of problem. That experience is currently encoded in people. Machine learning allows us to do kind of what we're already doing by training people on looking at examples. We can do that by doing the same process with a neural network. The AEC industry is already built around building partnerships that collect people around the requisite experience to solve some kind of building or engineering problem. The way that that experience is currently maintained is through people. Machine learning allows us to do a similar process by training on a library of examples, but we can do it directly in our tools. Machine learning is based on the ability to learn from experience. So you are able to collect examples of what you would like to happen and train directly on that rather than explicit rules of what you would like to happen. The AEC industry is already built around building partnerships where our partners have the requisite experience to solve some design or engineering problem. Machine learning will allow us to encode that experience directly as trained models rather than how it is now where we train people by looking at examples.
Awesome, let's cut.
At Teecom, we're working on applying machine learning in two directions. The first is building a custom software stack that directly integrates into our design tools. And this is everything from doing time series analysis on how we are currently using our tools to direct us on how to build better solutions in the future, to learning directly on the building information models themselves to do predictions about how to design technology systems using a neural network. At Teecom, we're working on applying machine learning in two directions. The first is building a custom software stack that allows us to use machine learning directly in our building information models. This can be anything from doing time series analysis over how we're currently using our tools to direct us to build better tools in the future, to learning directly on the building information models themselves to train neural networks to do some subset of the design that we already do that would be difficult, if not impossible, to describe in discrete logic. The second is what we're calling architecture ex machina. This is a kind of open source initiative that's designed to gather people, resources, experiments, anything that records our experience with applying machine learning to our design problems and opening that up to conversations with the rest of the industry. What we really want to achieve with architecture ex machina is to raise the level of discourse around the applications of machine learning to architecture and design. We really want this to be a valuable resource for anyone in or adjacent to architecture and engineering to learn about and think about and see experience with applying machine learning to real-world problems. Some questions that we can see arising from this are, how do I apply this to my work today? What can I use to see these tools in action today? Some issues that we can see arising from this are things like copyright, who owns the drawings that are produced by a neural network, who owns the data sets that are consumed by neural networks. Other things are what's going to happen to employment in the future? Is this going to take people's jobs? We see the ability of machine learning as a fundamental expansion of our abilities today in the same way that computer-aided design and building information modeling were in the past. So in the past, people doing design and engineering were responsible for everything down to the movement of the individual pencil making the lines. With the advent of machine learning, we see a transformation that will be similar to the incorporation of computer-aided design or building information modeling, where the explicit details, the explicit instructions to a machine of what to record about a building, those things become abstracted away, and people are able to focus on high-level discussions with their clients, with their partners, with anyone that they work with around how we improve the long-term goals of design and engineering. My name's Tyler Kovacic. I'm a design technology specialist here at Teecom. That means that I work on applying machine learning to our core design processes and technologies. At Teecom, we're excited about the potential that machine learning offers us because we see that it will make possible solutions to design problems in our tools that we build for ourselves that were intractable in the past. Machine learning is a fundamentally new kind of programming that allows providing instructions to a machine through a data set of examples rather than by providing explicit instructions on how to achieve the thing that you're interested in. So machine learning is fundamentally the ability to write programs with data rather than providing explicit instructions on what to do. We see this paradigm of programming as a natural fit for the complex functions that architects and engineers do every day, because these problems don't have a one-to-one relationship with their solutions. There are many possible solutions that could solve these problems, and that's exactly what machine learning is good at solving. So conceptually, machine learning allows us to program by learning from experience. So the architecture, engineering, and construction industry is already based around building partnerships that collect experience that's relevant to solving a particular design or building problem. Currently, that experience is maintained by training people in the history of a design or engineering firm. Machine learning allows us to do the same thing, but directly in our tools. By programming via learning through experience, the complex functions that architects and engineers do every day, those things will be exposable and testable by integrating them directly into the tools that we use, rather than having them sort of float around the history of particular firms. The foundations of machine learning have been around basically since the beginning of computing. They were first outlined in the 50s, but it took until around 2012 for the requisite size of data set and computing power necessary to train these models to make them generally useful. At Teecom, we're working on applying machine learning to our work in two directions. The first is building a custom software stack that lets us apply machine learning directly to our core design processes and technologies. This could be anything from a time series analysis on how we currently use our tools to help us make better decisions about which tools to develop in the future. And the second way is learning to do design and analysis directly on the spatial information of a building information modeling now. At Teecom, we're working on applying machine learning in two directions. The first is building a custom software stack that will allow us to apply machine learning solutions to our work with building information modeling. Sorry, I'm going to start that over.
Okay.
That was real bad.
No problem at all.
At Teecom, we're working on applying machine learning in two directions. The first is building a custom software stack that allows us to apply it directly to our building information modeling. This could be anything from a kind of time series analysis that helps us make better decisions about which tools to develop in the future, to spatial analysis directly on the building information models themselves, to training neural networks to do the parts of our design work that are too complex or difficult to describe in traditional discrete logic. The second way we've been calling architecture ex machina. This is a kind of open source initiative where we would like to gather information, ideas, resources, people around our experiments with applying machine learning to our work. We really want this to be a resource that's available to everyone in architecture, engineering, and construction, or in industries that are adjacent to it as well. There's a multitude of different questions that we think that will arise from developing this future of machine learning in architecture and engineering. Some of those include who owns the copyright of these things, who owns the data sets, and everything up to what is this going to mean in terms of employment. Fundamentally, we see this as being similar to the shift that happened with computer-aided design and building information modeling, where these abilities aren't going to take what we're doing now, they're simply going to transform what we're doing now and offer us new creative abilities in the future.